Hello everybody, this is Eric Sullivan again. We're going to be talking about loops in this video, and in this video in particular we're going to unpack what a loop is actually doing. A for loop in particular for this video. So let's jump in. I've got several examples here, and for each example what I'm going to do is I'm going to actually show you what my code looks like. It actually has the full loop in it, and then we're going to unpack that thing and see what's going on step by step. So example number one, I want to print the first 10 perfect squares. And my loop is this: for n in range 1 to 11, print this stuff. And you can see what I get. For n equals 1, I get n squared equals 1, n equals 2, n squared equals 4, and so on and so forth. So let's think about what this loop is actually doing, right? The word for tells the program, or tells Python, to just start with the first thing that's in this particular list, and then do the code inside. So the first thing it's going to do is say n equals 1, and then it will, I'm going to copy that, paste, and then it will print this. So the first time through the loop it does that. Now once it's done this line of code, now n equals 2, and it does it again. Once it's done that line of code again, now n equals 3, and it does it again. And so you can see that I'm actually slowly building up the code that I had before. So what this loop is doing is saying, hey, just go through each entry in that list, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then for each one of those, do all the stuff inside. And so I've done up to 4. Now I would do n equals 5, print, and so on. And I'm not going to do all the way out to 10. I think hopefully at this point you see what the thing is doing. Okay, so let's do one that's a little bit more challenging. Right? This was a really straightforward loop. This is kind of the hello world of loops. Like, we just want to do something really simple. Okay, so for example 2. Now this particular one requires that you've seen some plotting in Python, and if you haven't, that's okay. Probably just follow along with me. The plotting code is relatively straightforward. I want to plot the functions f of x equals sine of b times x on the domain 0 to 2 pi, and I just want to change this parameter b from 1/2 to 1 to 2 to pi to 2 pi, just a collection of different values of b. So before I enter the loop, I import all of the necessary libraries, and I create the domain, because remember, when we're building plots with matplotlib, we have to start by creating the domain. So that's what I did here. So when I unpack the loop, all of that stuff's outside the loop. I'm going to have it sitting there for me to get started. Okay, now let's think about the loop. The loop now says for b in, and then it just literally gives the list 1/2, 1, 2, pi, and 2 pi. And then colon, and then it says y is equal to sine of b times x, and plot that thing. Okay, so what this loop is actually doing is the first step through. It says b is equal to 1/2. Now I don't need to write it every time. I can just copy it. So I'm going to copy those 2 blocks of code. Oh, actually, I'm going to copy all of this. Copy, paste. Okay, so it does b equals 0.5, assigns y to sine of 0.5 times x, and then plots it. So first time through the loop, all I get is this. Then, once that block of code is done, I'm going to scroll up again. Once that block of code is done, that's indicated by the indentation. It goes up to here, goes to the next item in the list. So that's b equals 1. So I can take this code, copy, paste, change b to 1. Now I've got those 2. Once it's done that, it's going to change b to, I believe 2 was the next thing on my list. Let's double check. 2 was the next thing. So it's going to do b equals 2. And now I've got that one. Oops. Then it does b equals pi. And then finally it does b equals 2 pi. Okay, now the plot looks a little bit of a mess in the end, but so what? That's okay. The point of this was to say, B is going to one by one take on the entries that are in that list. Okay, let's do another one. I think I have 4 examples built here. We're just going to unpack all of these things one at a time. Okay, so we're going to build the sequence xn plus 1 equals xn plus xn minus 1. So if you think about this for a second, you may recognize this as the Fibonacci sequence, starting with the points 1 and 1. Now I want to print the whole sequence at each step of the loop. So in this case, I start with a list that is 1, 1. I'm going to print the x, so it does that. So that's all outside the loop. I'm going to copy that so that I get the same stuff down here. And now the loop says for n in range from 2 to 20. Now 20 was completely arbitrary. I just said, whatever, just give me a bunch of them. Each time I'm going to append the right-hand side of the sequence to the X list and then print it. So I'm going to copy that here. Oops, there we go. And now n was the counter. N was in range from 2 to 20, right? So technically n starts at 2. And the first thing I get is this one. I print off 1, 1, and then I do 1, 1, 2. Now n is going to increment to 3. And now I've got this one. Then n is going to increment to 4. And I've got this one. Notice what I'm doing is I'm just copying and pasting my code, changing the counter, and rerunning the code. That's really what a for loop is designed to do. It's just designed to run the same block of code over and over again, but at each time, the counter has been incremented to something different. Now, notice something a little bit interesting here. I started, in this one, I started with 2, but I didn't really need to because I never explicitly used n here. So I could have just said range 20 and just started the counter at 0. I actually went a little bit further, so I would have been range, 19, I guess. But it doesn't really matter because I was never explicitly using the n here. So coming in here, I could have said n equals 0, n equals 1, n equals 2, n equals 3, 4, and none of that really matters because I was never explicitly using it. Okay, all it was doing was keeping track of how many times I'd gone through the loop. And then, of course, we could keep doing this until we're kind of sick of it. And at this point, I'm sick of it. Hopefully you see what this pattern is. Okay, example 4 for a for loop. This one requires a little bit of calculus. So let's say I've got a function, x times 1 minus x. I want to approximate the derivative at, here we go, we approximate the derivative at the point x equals 0.25 with lots of values for delta x. So remember that we're looking at the difference quotient here, f of x naught plus delta x minus f of x naught all over delta x. And the limit is what we're actually trying to approximate here. So I've defined the function, I've defined the starting point, and now I could make a list of dx's that is 1, 0 0.1, 0 0.00, or 0 0.01, sorry, 0.01, 0.0001. I get a little tired of this. I'd rather have Python do that for me, right? But this is okay. I'm going to run this just to show you what it does. Okay, so for delta x equals 1, I've got this print command here. The slope of the secant line is whatever. Well, inside the for loop, I said little dx is in the list called big dx. That's this guy. So it's going to loop through those one at a time. So first of all, it took 1, plugged it in, and just did the right-hand side of the difference quotient without the limit, of course. And then I've got this nice little print command. So what I have, let's copy this. Copy, paste. Little dx is equal to 1. And then I get those 2 lines of code. Copy, paste. Okay, so the first time through the loop, it says for delta x equals 1. That's the first thing that was in the list. right? So dx is running through this list. It grabs the first thing, it calculates the slope, and then does this nice little print command. Then the loop is going to say, well, okay, I'm still in this list, so I'm just going to go to the very next one. So now I'm going to go do 0.1, and then it's going to print off the next one. Then it's going to do 0.00, or I'm sorry, 0.01, and print off the next one. And hopefully at this point you see what's going on. And off we go. Okay, now I did one other thing up here in the original code that was a little bit nicer than this line right here. This line is a little bit cumbersome because what if we wanted a really long list? So I'm going to comment that out and uncomment this one. Here I did 10 to the, or 10.0 to the negative array, NumPy array of 0, 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to come over here into a scratch cell. Right, what does np.array of 0, 1, 2, 3, 4, 5, 6, 7, 8 do? Okay, it just gives me an array. Okay, what if I put a negative in front of those? Well, that gives me 0, -1, -2, -3, etc. What if I do 10.0 to the, and then wrap that in parentheses? That gives me, well, 10 to the 0, 10 to the -1, 10 to the -2, and so on. So that was kind of a clever way for me to build 1, 0.01, 0.001, etc. So I can run that guy. It's really the same list as I had before, and the loop is going to do the same thing. Okay, I'm going to do another video on while loops, but hopefully this gives you a sense of how a for loop is actually working.